Hey everyone, welcome to the last lesson in Unit 3. I know this unit has been a really tough unit, a lot of word problems, a lot of reading, so we're kind of hitting the final mark here. So the last thing we got to talk about in this unit is something called consecutive integers. Okay, the aim today is I can create and solve equations that involve consecutive integers. One of the ways we can practice our ability to work with algebraic expressions and equations is to play around with problems that involve consecutive integers. Now I keep saying that phrase, consecutive integers, so let's talk about what that actually means. The integers are the subset of real numbers. So real numbers are basically any numbers other than non-real numbers. So let's say decimals, whole numbers, negative numbers, fractions. These are all real numbers. So integers are part of the real number set. Integers specifically are just positives and negative numbers. So basically no decimals. So integers are like saying no decimals. Okay. Consecutive integers are on any list of integers that are separated by one unit. So 1, 2, 3. 5, 6, 7, 8, negative 4, negative 3, negative 2. Basically, consecutive means in order. So if I say that, like, we're going to list the group of the class by birthdays consecutively. So we'd start with a student that started in January and then go into February and March. So it's something that's in order. Okay? We have two different types of consecutives. We have consecutive evens and we have consecutive odds. So even numbers are like 4, 6, 8, 10, 12, and odds are like, 3, 5, 7, 9, 11. Okay, so that's all the vocabulary in this lesson. Integers, consecutives, even, and odds. So let's take a look at exercise 1 and talk about the kind of work we're going to do with consecutive integers. Okay, let's work with just two consecutive integers first. Say we have two consecutive integers whose sum is 11 less than 3 times the smaller integers. Okay, now this takes us back to the earlier lessons where we have to break this up by translating. So let's look at A. It's important to play around with this problem numerically. Numerically means use numbers to try things out first. So let's try a variety of combinations and see if you can find the correct pair of consecutive integers. Okay, so we want two numbers whose sum is 11 less than 3 times the smallest integer. So let's pick two different integers that are consecutive. So let's try 2 and 3. Those two numbers are consecutive, and let's see if it works. The sum of those two things, so what's the sum of 2 plus 3? The sum of 2 plus 3 is 5, so there's my sum. And that sum is 11 less than 3 times the smaller integer. So the smaller integer is 2. So 2 times 3 is 6. So now the question is 5 11 less than 6? No, it's not. Nope. So 2 and 3 don't work. Okay, let's test another two numbers. Let's try 10 and 11. Okay, so the sum, 10 plus 11 is 21. And so that's my sum. And now let's do 2 times, or sorry, we're looking at the 3 times. 3 times the smaller one, well, 10 is the smaller one, is 21 11 less than? No. So 10 and 11 doesn't work either. So this could take us quite a long time if we wanted to just guess and guess and guess. So instead, like previous lessons in this unit, let's set up let statements for this. So here's my original phrase, 11 less than 3 times the smaller integer. Okay. Consecutive integers have an interesting way we set them up, and you have to memorize this. So, consecutive integers. The first integer will always be x. Always, always, always. Your first integer is x. How many more than x would the next number be? So let's pretend that x is 2. What would my second integer be? 3. If x is 4, what would my second integer be? 5. So how many am I always adding to the first integer? 1. So the second consecutive integer is always going to be the first number plus 1. This you need to memorize. Okay? The third integer, if we had one, now keep in mind this problem only has 2. If you go back up, it only wants 2. But if we had 3, it'd be x plus 2, and so forth. So now that we know these two things, now we can use our original statement. So we're looking at the sum. So the sum of these two numbers, x plus 1, there's my sum, right there, I'm going to circle it way up top, is, let's use a different color for is, blue, is my equal sign. And then let's translate that last part. That last part says 11 less than, so that's a minus 11, because we flip it when we see less than, 3 times the smaller integer. So 3 times the smaller integer, 3 times the smaller integer would be 3 times x, because x is smaller. So I'm translating. Now that I've got an equation, I can simplify it. X plus x is 2x, they're like terms. I'm going to bring down the 1. 3x minus 11, I can't do anything with that. Now I can try and get my x on the left side, so I'm going to subtract x from both sides. These x's cancel out. 2x minus 3 is negative 1x. Bring down the negative 11. Now I've got to get the 1 over on the other side, so I'm going to subtract it. These cancel out, and I'm left with negative 1x equals negative 12. Now I can't have a negative in front of here, so I'm going to divide it away and get x equaling a positive 12. Now if x equals a 12, we have our first integer. What would our second integer be? Our second integer would be 13, because x plus 1 is 13. So our answer to this problem is 12 and 13. Now I could check it. I could say, okay, well, what is 12 plus 13? 12 plus 13 is 25, and 3 times 12 is 36, and is 36 minus 25 11? It sure is. So both the sum works and my 11 less than works as well. Okay? So the key thing to remember is this right here. When you're defining your integers, the first is always x, the second is always x plus 1, the third would be x plus 2, and so forth. Okay? Let's take a look at exercise 2. Let's try some more problems. We always encourage to play around with numbers before you go to the algebraic setup. The algebra should flow from what you do with the numbers, not the other way around. So like I've said in the past in other lessons, if you're struggling, plug in pretend numbers and see if the math works that way. Okay? Exercise 2. I'm thinking of 3 consecutive odd integers. So I'm going to stop right here. Okay? I'm just going to put a line there, so I'm going to stop. 3 consecutive odd integers, so I'm going to define these integers first. So let's define my integers. The first integer, okay, is, let me do this again. My first integer is always going to be x. Now this says they want odd integers, so we have to think about something. If my first integer is the number 1, I'm going to write it up here. My first integer is number 1. What would the next odd number be? It wouldn't be 2, it would be 3. And then what would the next odd one be after that? 5. How many does it take to get from 1 to 3? You have to do 1 plus 2, correct? And then from 3 plus 5, you do 3 plus 2 to get to 5. So, unlike the last problem where we did x plus 1, now the second integer, because we have odd, is going to be x plus 2. Okay, now this problem wants us to have 3, so the third one would be x plus 4. Alright? So now we've defined our integers. The first one would be x, the second one would be x plus 2, and the third would be x plus 4. Now we can go on to the other part of the problem. The other problem says when I add the larger 2, okay, so I'm going to stop right there. When I add the larger 2, adding means we have a plus sign, and the larger 2, these two are my larger 2. These are my larger 2, so when I add them together, x plus 2 plus x plus 4, okay, that takes care of this part. The result, so that's another fancy way of saying we're going to put in an equal sign here. So the result is 9 less, remember 9 less than means we have to reverse the order, so 9 less than, it's going to be a minus 9 at the end. 3 times the smallest. So 3 times, that's 3 times multiplying. The smallest, this is the smallest. So I'm going to have 3x minus 9. And that's my translation in my equation I've created. Okay? That's the hard part. The hard part is setting up your consecutive integers and creating your equation. The rest is just solving. So this is the part over here. I'm going to put a box around it to memorize definitions. And if you want, you can always come up and ask me for guided notes for this or ways to help memorize when you see me in class. Okay? Alright, now we just have to solve this problem. So I'm going to combine like terms. I have 2 x's here, so that gives me 2x. And then I've got a 2 plus a 4, that gives me an 8. Bring down the 3x minus 9 because we can't combine them yet. Like I said, always try and get your x term on the left, so I'm going to subtract x on both sides. Those x's cancel out, and the x's on the left add up to negative 1x. Bring down your 8, and bring down your negative 9. Now I want to get x alone, so I'm going to subtract 8 on both sides. The 8's cancel out, and I get negative 1x equals negative 17. And then I got to get rid of that negative, so I'm going to divide it away. They cancel out, and I get negative 17 divided by a negative 1 is a positive 17. So what does that mean? Well, that means that 17 is my first integer. If 17 is my first integer, what's my second integer have to be? Well, we're looking at odd numbers, so the next odd number there is 19. Do you see how now it's x plus 2? Because it's the next odd integer. I know it's weird because 2 and 4 are even numbers and you're working with odds, but when you finally figure out that first one, odds and evens are always separated by 2, no matter what. So this means my third one is 21. So my final answer is 17, 19, and 21 are my 3 odd integers. Okay? Alright. Exercise number 3. We're just going to keep practicing with these types of problems, okay? If you want, you can always try these on your own with these exercises and then check and see if you're correct. I highly encourage it, especially this unit when you're really trying to learn the material, okay? 3 consecutive even integers have the property that blah blah blah. You guys need to learn to stop when you have a little bit of information. So I'm going to stop at 3 consecutive even integers. I know that's what I'm working with. I know I need to define them, so I'm going to stop before I even read the rest of that problem. Okay, I'm going to define them as the first is always x, the second, now these are even integers. Now evens and odds are both separated by 2, so the second one is still x plus 2. Because pretend numbers in. If I start with the number 2, what's my next even? 4. And then 6. What are they separated by each time? 2. So it's always x plus 2, whether it's even or odd. Okay? I'm working with 3 of them, so I'll need a third one, and that's going to be x plus 4. Okay? Now I can keep going with the problem. They have the property that when the difference, that means subtract, between the first and twice the second. So the difference between the first, so here's the first, and that's where I know I'm going to put my minus sign. Okay, I'm not going to put my minus sign in the front. That and clues me in that here's the first. There's my first one right there. And there's my minus sign. Twice the second. So minus 2. Now the second is this x plus 2. So I'm not going to do this, because that's only twice x. I need to put parentheses and say that it's twice the whole thing. Okay, that's a tricky part about this example. It's twice the entire second integer, which is x plus 2, so we have to use a grouping symbol to group that. Okay? Let's keep translating. This is found is a fancy way for having an equal sign. Same thing with the result here. Is found, the result is, so I'm going to put an equal sign. 8 more than, that's basically 8 plus, 8 more than the third. Well, we already defined the third as x plus 4, so I'm going to put an x plus 4 here. There's the third. Okay? And again, if this is confusing to you or you have questions, that's what I'm here for in class, or to email or to text. Okay? Because this is a really tough lesson. Alright, now I'm going to start solving this equation. I'm going to bring the x down. Don't subtract the x and the 2 first. Distribute the negative 2 first, so I get negative 2x. then negative 2 times a positive 2 is a negative 4. Bring down, oh, whoa, wait, I didn't see this. 8 and 4 are like terms, so that becomes 12 plus x. Okay, next step, I see that x and 2x are like terms. Well, there's like an invisible 1 here, so it's like saying 1 minus 2 would give me a negative 1x. Just bring down that negative 4 and bring down the 12 plus x. Okay, now we're in that same situation where I got to get my x's on the left side, so I'm going to subtract. This is like saying I've got an invisible 1 again, if that helps you. They cancel out. Don't get fooled by the signs here. Negative 1 minus 1 is negative 2. They don't cancel out. They only cancel out if the signs are opposite. Bring down the negative 4 and 12. Now add 4 on both sides, and you get negative 2x equals 16. Last step, divide by negative 2, and I get my first integer to be negative 8. So if my first integer is negative 8, now be careful here, negative 8, what would my second one be? It wouldn't be negative 10 because then I'm going backwards. So negative 8 plus 2 is negative 6, and the next integer after that is negative 4. So this is my final answer. Negative 8, negative 6, and negative 4 are my consecutive integers. Okay? Let's take a look at the last problem. This one looks pretty simple. The sum of 4 consecutive integers are negative 18. Actually, this is probably the easiest one in the whole lesson. First thing we're going to do is define our integers. I like this problem, I'm excited. Define. How many integers do we have? We have 4 of them, so that's 4 integers. The first one is always x. The second one, we have to think about, are these even or odd? No, just consecutive, so that's separated by 1. The third one would be x plus 2, and the fourth one would be x plus 3. Okay, so there's my definition. Again, if you're confused, you don't have to write this down on your notes, but let's just think of an example of consecutive integer. Let's pick the number 5. What would the next number be? 6, and then 7, and then 8, right? Well, let's say 5 was x. Wouldn't 8 be x plus 3? 5 and 5 plus 3, doesn't that equal 8? Yes. So if you're confused about where I'm getting these x plus 1, x plus 2, plug in some real numbers. I'm getting them from the definition of consecutive integers. And they'll always be, that's kind of why consecutive integer problems are nice, because they'll always be that way. No matter what problem you have, they'll always be defined this way. Alright? Now what are we working with? We're working with the sum of all 4 of them, which is what makes this problem easy. Sum means we add them all up, so I'm going to say x plus x plus 1 plus x plus 2 plus x plus 3. I'm using different colors to show you that I'm adding these 3 different integers together. Okay, there's the first one, there's the second one, there's the third one, and there's the fourth one. Okay, I'm not going to write those little lines in because it makes solving it hard, but I want you to see that I'm writing their sum. Okay, the sum of them is, there's that keyword is that gives me my equals sign, is negative 18. Okay, negative 18. So there's my equation. Now we have to combine like terms and simplify. How many x's do we have in this problem? Count them. We've got 1, 2, 3, 4. So 4 x's gives me 4x. Sometimes I like to cancel these out just so I know I didn't miss any. 1 plus 2 plus 3, that gives me a 6. Use your calculators please if you're unsure. Now I solve. Subtract 6 on both sides. The 6's cancel out, and I get 4x equals negative 24. I believe 18 to 24. I don't have a calculator with me, so I'm doing this in my head, which is why in that one lesson I said that 5 plus 5 is 30, so I don't want to make that mistake again. The 4's cancel out, and x gives me negative 6. That's my first integer, is negative 6. Now be careful, because your second one is going to go up, not down, so it's a negative 4. Your third is negative 2, and your fourth integer is a 0. Now, if we want to test this, oh, what did I do wrong? I'm so sorry, I did consecutive evens. Sorry, it's negative 6, negative 5, negative 4, and negative 3. See how easy it is to make mistakes? Now let's test our work. Let's actually see if the sum of this is negative 18. So negative 6 plus negative 5 plus negative 4 plus negative 3. Okay, well, negative 6 plus negative 5 is negative 11. I'm using PEMDAS. Use your calculator too. Negative 11 plus negative 4 is negative 15. And negative 15 plus negative 3 is negative 18. So yes, my answer is correct. Okay? One quick thing I want you guys to have written somewhere, and I think it's important that you write this down. Consecutive integers. Always your first is x. Your second is always x plus 1. Your third is always x plus 2, and so forth. You're always adding by 1. Okay, that's consecutive integers. Okay, if you have consecutive even or odd integers, that just has one different rule. Consecutive even or odd, you add by 2. So it might be helpful for you to write this down somewhere in your notes. Your first is always x, but in consecutive even odd, your second one is 2, your third one is x plus 4, your fourth is x plus 6, and so forth. So you might want to have this written down in your notes somewhere. You need to memorize this. Okay? So when you come do mastery, and or your fluency first, and you're trying to wonder how to set up these problems, this is how you set up your consecutive integer problems, okay? Good luck. I know this unit has been really challenging, but I know you guys are up for it. So ask me for help if you need it, and I will see you in class.